functional stuff measures sort of hemoglobin, right, uptake, oxygen uptake, and and this is in some ways static. So it's a pretty neat modality because it's not functional and yet it's capturing something beyond just shape. It's capturing some underlying tissue structure.
Okay.
So one of the things that people are interested in doing is defining these pathways. And one of the ways to define them is to basically compute through the whole volume a set of shortest paths between things that, and you do that by solving an equation that takes into account the anisotropy of this structure. So you have to now use your imagination. I've got this whole set of like 5. So here's the solution. And so let me show you what the solution looks like. Okay, so here's the solution. So here's the set of sort of fiber connections, best fiber connections between those two paths.
Okay.
Okay, so what we do is we use this. Let me kind of fix this visualization a bit. So what we do is we use this to then define regions in the image that we can study. So we'll go in now and we'll do statistics on these pixels that connect these 2 points. And so what we've done with the arc of fasciculus, the arc of fasciculus connects 2 regions of the cortex. One's called Broca's region, the other's called Wernicke's. And so we had people go in and identify those regions, and we find the path through the diffusion data that connects those, and then we do statistics on those paths, and we can find differences in people that have autism versus people that don't have autism. So now we know, at least, that the arcuate fasciculus is different. Now we don't know, it's a chicken and egg. Is it different because of the way people use language, or is it different? Yeah, exactly. So and this is what we'll tease apart as time goes on.
A question that Pat Sherman, the ferret thing when you put the...
And even in this study, like we studied arcuate fasciculus, right? And most people are lateralized language, right? So we tend to do language on the left, right? And so we have to actually remove subjects that don't lateralize, because there are subjects that are using their brains a little differently. You know what I'm saying? First of all, we get rid of all left-handers because they don't lateralize the same way other people do. And then we have to get rid of all subjects that are not showing the typical lateralization, because the problem is there's evidence that the circuitry is probably a little different in these people, and they'll mess up the statistics. This data set, this is the visible human. So this is that data set that NLM commissioned some years ago. And so the idea is this is a big data set, and we've got a hierarchical sort of mechanism for pulling this data on and off the GPU, and we've got a couple of other nice features. So this is what they call this sort of flashlight, right? This clear view that allows you to go through and see different layers in the tissue. So this would be used, for instance, let's say in teaching or medical illustration. You remember a lot in medical illustration, they'll do this thing, right, with cutaways.
Right.
So this would be a way of sort of automatically doing these cutaways. And and so if you want to get really fancy, you don't want to put that on film. You notice I moved by that pretty quickly. If you want to get really fancy, we can put on the 3D glasses. This is pretty cool in 3D. So the right should go on your left eye. The red should go on your left eye. So this you won't be able to see on the camera, but you'll get an idea. So I think you have to bend them a bit. So and yeah.
The patella really sticks out there.
Yeah, isn't that amazing? It looks like it floats. Okay, so we've got a little bug.
What function does the patella actually, looks like it's useless.
Yeah, right. So, I mean, I think, for instance, it's a good question. What does it? That's a really good question. I never thought of that. But you do get a sense here of how much it sticks out, right?
Yeah. Here, try it out. Does it work?
Yeah, mostly.
Lots of them there.
No, I really need this.
Okay, so give me a second here. This is a little bit... Yeah, this looks all right to me. But that knee doesn't look... Does that look right to you guys? Let me fiddle with this...
I've never had luck with that.
Yeah, it's probably better straight on. There you go. It is better straight on. There's also some glare that's messing up one of the eyes.
I must have...
Oh, I see. Yeah. Let me turn off this clear view. I agree with you. That doesn't look right to me. How about this? So when it moves, it looks fine to me. Yeah, that looks right to me now. Yeah, that clear view isn't right, is it?
It's not really jumping out at me.
It's
Like
not
the